In this video, I am going to set up a 5-node Elasticsearch cluster with Kibana. Before we get started, I should outline what we need, and I should also define a few glossary terms as well. Let's start with the resources we need for this tutorial. I will be using 6 different Ubuntu machines. 5 will be used for Elasticsearch nodes, and 1 will be used for Kibana. I also prepared 6 publicly signed SSL certificates ahead of time for these 6 domains. If you want to use publicly signed certificates and you don't have them yet, you can generate some for free with Let's Encrypt. I will leave a link in the description of this video to another video that shows you how to generate Let's Encrypt SSL certificates that you can practice with. If you have your own certificates, that's even better, and things should also work with wildcard certificates. Next, let me quickly cover a few glossary terms and concepts. Let's define a node and a cluster. An Elasticsearch cluster is a collection of Elasticsearch nodes. When you start up one instance of Elasticsearch, it is one node running in one cluster. One of my earlier Elasticsearch installation videos demonstrated this, where we had one machine for Elastic and one machine for Kibana. The single Elastic machine was a single Elasticsearch node running in its own cluster. You can spin up more machines, each with Elasticsearch installed on it, and then connect these machines to the cluster. Then you will have many nodes in the cluster. The benefits of a multiple node cluster is that it helps with scalability and resilience. A multiple node cluster is more scalable because it can distribute resources and capabilities amongst many nodes. And it helps make your overall Elasticsearch service more resilient and fault tolerant, because any node that experiences service interruption can automatically be replaced by other active nodes. Next, let's talk about roles for a node. A role defines what capabilities and responsibilities a node can have. You can see on this page here that a node can have many roles. If you don't explicitly declare them, then all these roles are assigned by default to a node. The 2 most important roles that you need to be aware of are the master role and the data role. When you start a cluster, there must always be one node that is designated the master node. And reading from this definition here, the master node is responsible for lightweight cluster-wide actions such as creating or deleting an index, tracking which nodes are part of the cluster, and deciding which shards to allocate to which nodes. In terms of which node is the master, any node that has been assigned the role master is eligible to become the master node. When you start up your cluster, some of the nodes in your cluster will vote on which master eligible node actually becomes the master node. If a master node becomes unavailable during runtime, the remaining nodes in the cluster will select a new master node. So that is the importance of the master role. For the data role, it is much easier to understand. Any node that has been assigned the data role can store documents for your index. So there are quite a few other roles that you can look into, but you can learn about them as you go. That is my introduction. We can get started now. I will leave a link in the description of this video to all the configuration files I'm about to use and any resources I'm about to mention. I have 5 Linux machines out in the cloud somewhere, each with different IP addresses. Some machines use Ubuntu 20.04 and others use 22.04. Each machine is labeled with a hostname like node 1, node 2, all the way to node 5. And I also have domain names like node1.evermite.net all the way to node5.evermite.net mapped to each corresponding machine. So you can see, for example, node1.evermite.net corresponds to the IP address of 172.105.3.82, which is the address of node 1. Because all these machines are new instances of Ubuntu, I'm going to update the distribution as well as install some packages that I may need, like the Vim editor, curl command, newpg, and gpg. So let me update each of these machines. Okay, apt-get update, apt-dist upgrade -y for automatically agree to everything, and then install vim, curl, newpg, and gpg. And I'm going to copy this and just paste it to every single machine, and then I'll just run it. And I'll come back when everything's done. So node 1 is done, the others are still going, but let's get ready to install Elastic anyway. We're going to use the apt-get approach, so let me pull up the documentation. And it's pretty straightforward. Just get the public signing key, install a dependency, update the repository definitions, and finally install Elastic. So what I'll do is just copy each of these commands into a shell script. That way I can use it multiple times on each machine. So I'll just fast forward through this cut and paste part. Okay, everything is in there. So let me just change the permission on this file. And then I'm gonna SCP this file over to each of the servers. So I'll just fast forward through this part as well. Okay, install.sh is on every single server. So I'm just gonna run it on each of them, and I'll come back when everything is done. All right, all the installations are done, and on each instance of Elasticsearch, each node comes with a built-in super user account, the username being Elastic, and here's the password for the Elastic user on node 1. And if I go to node 2, if I scroll up, we're going to see the password for the Elastic user on node 2. Here it is. This is the password for the Elastic user on node 2. And node 3, node 4, node 5, they all have different passwords as well. And none of this matters because once I set up the cluster, I'm going to reset the password for one Elastic user, and it will be used across all nodes in the cluster. So let's go to the etc Elasticsearch directory, and in here you're going to see the default configuration files that come with our installation of Elastic. Let's edit the main one, elasticsearch.yml. There's only a few things in here that we need to edit to set up our first instance of Elastic as well as our cluster. So let's go through this. I'll start with editing the cluster name. We can call it anything we want. I'll call mine ESDemo. Other nodes are going to need to know this name to connect to it. Next, I'm going to edit the node name. I'll call it node 1, and we should make sure that this name is unique within our cluster to avoid any naming collision. Next, I will edit the network host, and I'm going to use the domain name that maps to this server. So node 1 Evermite net. And for the port, I'll use 9200, but you should consider using a non-default port for security reasons. Next, we need to decide on how to configure SSL certificates for HTTP communication, which is typically used for Elasticsearch REST API. We could either use our own publicly signed certificates, or we can use the self-signed certificates that were automatically generated by Elasticsearch during installation. And just so you know, the automatically generated self-signed certificates can be found in this directory, so inside this certs directory. Most of the documentation on the Elasticsearch website discuss using self-signed certificates. This is because later in the video, you will see that Elastic comes with command line tools for working with your Elastic instances. Some of these tools depend on the use of self-signed certificates. And based on what I understand, these tools require specific details of the root or intermediate certificates that come with Elastic's auto-generated certificates. So if you use publicly signed certificates or commercial certificates from authorities like Let's Encrypt, GeoTrust, GlobalSign, and others, you will not be able to benefit from some of Elastic's command line tools. And if you use publicly signed certificates, then you will also need to manually edit various configuration details to get a single Elastic instance working or to get the whole cluster working. So the benefit of using Elastic self-signed certificates is that you can benefit from Elastic's command line tools. The inconvenience of using Elastic's self-signed certificates is that you need to put in more effort configuring SSL verification between Elastic and other client applications that need to connect to Elastic. This is because client applications won't automatically trust self-signed certificates unless you continue with extra configuration. In the near future, I will create a video on SSL Trust Chain that explains all of this in more detail. But for now, just know that there are trade-offs between using publicly signed certificates or Elastic's auto-generated self-signed certificates. So in terms of what we're going to do, we're going to use Elastic's self-signed certificates to start off. That way we can benefit from a command line tool that will generate enrollment tokens to enroll other nodes into our cluster. Then once our cluster is up and we no longer need the command line tool for generating enrollment tokens, I will swap out these self-signed certificates with our own publicly signed certificates from Let's Encrypt. And that will make it easier for other client applications to connect to our Elastic cluster. So for now, I'll leave these two lines alone. Next is the transport SSL. Elasticsearch uses the transport protocol for communication between nodes in the Elastic cluster. And here, you also have a choice between using Elastic's auto-generated self-signed certificates or publicly signed certificates. Again, Elastic's documentation is mostly around self-signed certificates. And based on my own research and experiments, it seems that the Elastic cluster will allow nodes to join your cluster if the nodes have specific root certificates in the trust chain. So for simplicity's sake, what I'm trying to say is that the self-signed certificates almost act like access tokens between a node and the cluster. Let's consider the other alternative where you use commercial or publicly signed certificates to encrypt the transport protocol. In this situation, your Elastic nodes are using root certificates that are publicly available to everyone, which means any stranger in the world can set up an Elasticsearch node and connect to your cluster without any restriction or authentication. And I've done some experiments that verified this was the case. If for any reason you choose to use commercial or publicly signed certificates for the transport SSL, make sure you set up a firewall to limit access to your cluster. Also, check the documentation because from what I read, Elastic will use ports in the range of 9300 to 9400 as the default for transport communication. So you may want your firewall to restrict access on those ports. And also, you generally don't want Elastic to be publicly accessible. You should take the same safeguards protecting your Elastic cluster the way you would protect a mission-critical database. So with that said, we will use Elastic's auto-generated SSLs for the transport protocol, and we'll leave these settings as is. The next line to look at is the cluster.initialMaster nodes. As far as I can tell, this field is only needed the first time you start up this Elasticsearch instance, which also sets up the cluster that this node belongs to. Afterwards, I don't think this line does anything. The value should be the node name of this node, which in this case is node 1. If this value was not set, Elastic would just take the hostname of your Linux instance, which might actually cause some problems with your cluster. So make sure you set the initial master nodes properly before you start the cluster. That should be all we need to edit. Now we can try to start up the cluster with just this node. So this might take a minute, so I'm going to pause until this is done. Okay, so let's check the status to see if anything failed. Great, everything seems okay. So what we should do next is ping the API to see what the cluster health is. But I don't remember the password for the Elastic super user, so I'm going to reset it. So I'm going to go to USR share Elasticsearch binary directory. And in here are the command line tools that came with our installation of Elasticsearch. So I'll reset the password for the Elastic user with this one here. Elasticsearch reset password interactive user Elastic, and we'll give it a moment. Yes, and I'll use the password ABCD1234, but you guys should use something more secure. All right, now let's ping the Elastic API. So I'll just curl elastic abcd1234 node 1 evermite net 9200. Oh, all right, because we're using self-signed certificates. So I'm going to skip verification with this -k flag. There we go. There, we can see that our Elasticsearch cluster is up, but it's not showing any node. Oh, okay. Let me just do _cluster health. Let's pretty this. It's hard to see like this. There we go. Now we can see that there's one node in our cluster, and the name of the cluster is ESDemo. There are a few other useful commands. So let me just type this here. Cat nodes. This lists all the nodes in your cluster. The asterisk reflects the node that is the master node. And another one that's useful is cat master, which explicitly tells you which node is the master. All right, so we've got our cluster up with one node in it. We're ready to add a second node to our cluster. I pulled up the documentation on how to add a node to the Elasticsearch cluster. It's pretty straightforward. However, these instructions are only relevant if you're using the Elastic's self-signed certificates for both the REST API and the transport protocol. If you are using publicly signed certificates, then none of these instructions will work, and you would need to configure the other Elastic nodes manually. So if anyone needs to know how to configure nodes manually for use with publicly signed certificates, just make a request in the comments below, and I will post a follow-up video on how to do it. Adding nodes to the Elasticsearch cluster can be pretty straightforward if we use the command line tools that come with Elasticsearch. So let me scroll down. So we start right here. This Elasticsearch create enrollment token command comes with the installation of Elasticsearch. So you can see it right here. And you have to run this command from node 1. And once you do, it generates a token which is then used by a different command on node 2, or the node that wants to join the cluster. So once you have the token, you take the token and go over to node 2 and you use it along with this command over here. No, wait. Actually, this is not correct. This command will start up node 2, which we can't do because we haven't even configured it yet. So let me pull up a different documentation. Okay, yes, this is the right command, the Elasticsearch reconfigure node. We will see that this command also exists on node 2 because it comes with the installation of Elasticsearch. So let me just show you. Let me find my second window. Yep, here's node 2. And I'll go to the USR share Elasticsearch binary directory, and you can see that the Elasticsearch reconfigure node is right here. So in terms of what this command does, when you run this command on node 2 with the token generated from node 1, it will do a couple of things. First, it will edit node 2's elasticsearch.yml file to contain some connection details to the cluster. And second, it will cause node 2 to generate some new self-signed certificates that will work against the cluster. And like I said earlier, these self-signed certificates basically act like access tokens to the cluster. There's another thing to keep in mind. This Elasticsearch reconfigure node command assumes you haven't touched anything in node 2's etc Elasticsearch directory. If you've made any changes in node 2's Elasticsearch directory, this command will fail with some errors. And from my experience, the easiest way to get around these errors is to just completely rebuild the server and reinstall Elasticsearch and then try again. So let's try this all out. I'm going to go to node 1, here it is, and let's generate the enrollment token. I'm going to use the Elasticsearch create enrollment token, S for scope, and type node. And now let's just wait. Here it is. Here's the token. So I'm going to copy this. And before I use it, I actually want to show you something interesting. Gonna open up Firefox, gonna go to developer tools and use some JavaScript. I'm gonna type a function atob and paste in the token. So atob is basically base64 decode. So I'm gonna base64 decode the string and we're gonna see what's in it. So you can see this is what's in that token. It's basically connection details to node number 1 and the version of Elastic on node 1 along with some of these keys over here. So now we glean a little bit of insight into what this elasticsearch reconfigure node command does. It's basically parsing out some connection details from the enrollment token and probably using some of those other secrets we saw to generate the self-signed certificates. So that's all useful information. Now let's continue with this enrollment token. I'm going to copy it from node 1, then I'm going to go to node 2, and let's use the elasticsearch reconfigure node command, and I'll pass in the enrollment token. So let's paste it like this. Yes. Okay, that should be good. So now we go to the etc elasticsearch directory, and then I'm going to open up the YAML file, and let's go all the way to the bottom. So what you see here is that the discovery.seedhost field has been populated with the IP address of node 1. So basically this was done by the reconfigure node command. This means that when node 2 starts up, the first place it's going to look is at node 1 for information on how to connect to the Elastic cluster. The other thing the reconfigure command did was uncomment this line here for transport.host. So to summarize what the reconfigure node command did, it populated the discovery seed host field, it uncommented the transport host field, and it probably generated new self-signed certificates that would work with the cluster. So now it's up to us to manually configure the remaining fields in this file. And there's only a few fields. So the first is the cluster name, and it has to be exactly the same as the actual cluster name. So let's go find that. I'm going to hit our API endpoint at _cluster health. And there it is. So I'm going to copy this cluster name and I'm going to paste it in here. All right, next let's set the node name. And remember, it has to be unique within the cluster. So I'll call my node 2 and coming down. Let's set the network host to node2.evermite.net. And let's set the port. And let's see what else. Okay, so SSL certificates. We should not edit the SSL certificates for the transport section because those will use Elastic's self-signed ones. But for the REST API, we will use our own Let's Encrypt SSL certificates. So I'm going to upload them here. Let me make a new directory. There we go. And I'm going to find my local machine. Give me a second. Here it is. All right. So I have all the SSL certificates made ahead of time, and they're here on my local machine. So let's take a look at node2.evermite.net. Right, so those are certificates for node 2, and here are certificates for node 3. So I'm just going to SCP these certificates onto node 2 server. Right, Elasticsearch, certs node2.evermite.net. There we go. So let's just make sure they're all here. Oh, I have to change the ownership of these files. Let's own Elasticsearch. All right, now let's check again. Great, all our certs are here. And the permissions look okay as well. So now let's update the path to our Let's Encrypt certificates so that we can use them for the REST API. So key certs node2 evermite.net / privkey1.pem, and the certificate is the same path, but now it's just fullchain1.pem. And I think that should be it. Oh, I forgot to mention one more thing. On node 1, we're using the self-signed certificates for the HTTP/SSL. But here on node 2, we're using the publicly signed Let's Encrypt certificates for the HTTP/SSL. And the reason why on node 2 we can use the Let's Encrypt SSLs is because I don't plan on using the command line tools anymore on node 2. So I might as well just use the publicly signed certificates here. And even if I did need to use the command line tools on node 2, I can always just swap out the Let's Encrypt SSLs with the self-signed ones on node 2, restart Elastic, use the command line tools, and then when I'm done, just swap things back again. So I think that's it for this file. I think we can actually try to start up node 2 and see if it will connect to the cluster. So let's go systemctl enable Elasticsearch. And let's systemctl start Elasticsearch. And this might take a moment, so I'm going to pause. Okay, it's been about 15 seconds only. I'm going to systemctl status Elasticsearch. Great, this looks good. Let's go to node 1 and ping the API. Oh, great. So there are 2 nodes in our cluster, so that's a good sign. Let's try to get a list of nodes. All right, cat nodes. Great, there are 2 nodes, but I misspelled node 2 as node 1, so let's fix that. I'm on node 2, go to node name right over here, and I'm going to change that to 2, and let's just restart. All right, let's give it a moment. Okay, node 2 should have restarted. Let's go back to node 1 window and get a list again. Great, I fixed the typing mistake for node 2. So up until now, we've been hitting the node 1 API endpoint. And in theory, we should be able to hit the node 2 API endpoint and get exactly the same details. Plus, on the node 2 server, we're using the publicly signed Let's Encrypt SSL certificates. So when we hit the node 2 API endpoints, in theory, we shouldn't have to add the -k flag to our curl statement because the -k flag skips the verification mode. So let's actually try to hit node 2 API endpoint and do the full SSL verification and see if we actually get the same details. So let me pull up the old command. Let's remove the -k flag and let's change this to node 2. Great, these look like the same results. And if I take this command and run it from node 2, it should be the same result as well. Yep, so that's the same as well. Now that node 2 is up, let's summarize what we did to make it a part of the cluster. First, on node 1, we ran the Elasticsearch create enrollment token -s node, and that gave us a token. We took that token and we went over to node 2 and we ran the command Elasticsearch reconfigure node --enrollment token, and we gave it the token. And what this command did was it edited our Elasticsearch YAML file, and it also generated some self-signed certificates that will allow node 2 to connect to the cluster. Next, we opened up the Elasticsearch YAML file and we edited the fields cluster name, node name, network host, network port, and we also edited the xpath.security.http.ssl fields. The HTTP/SSL could have been optional. We could have used self-signed certificates there if we wanted to. We then reviewed the fields for discovery.seedhost and transport.host. We noticed that the reconfigure node command populated the discovery.seedhost field with some hosts from the Elastic cluster. So in our case, just the IP address of node 1. We also noticed that the reconfigure node command uncommented the transport.host field. So in the next part of this video, I just finished repeating these exact same steps for node 3, 4, and 5, and they are all using the Let's Encrypt SSLs. So what I want to do next is I want to go to node 1 and I want to swap out the self-signed certificates with the Let's Encrypt certificates. So let's go ahead and do that. This is the SSH window for node 1. You can see node 1 is part of a 5-node cluster and node 1 is the master. So let's replace the self-signed certificates with Let's Encrypt certificates. So I'm going to go to the etc elasticsearch directory of node 1 and let's open up the YAML file. So I think the only thing I need to change is the path to the HTTP certificates. So I'm going to type key and I'm going to upload the private key over here. So I still have to upload it. Just let me type in the path first. And I'll copy this line, paste it. And for the certificate, I will upload it to here, full chain 1. Okay, so let me make the directory certs node1.evermind.net. So I'm going to upload it here. Let me go to my local machine, upload to node 1, copy from my node 1 directory. All right, everything should be there. And let me just change the ownership to make sure Elasticsearch owns all these files. Oh, typing mistake, not chmod, should be chown. All right, so let's check the permissions. And if everything looks good, we just restart node 1. Yep, this looks good. Yeah, so now we just restart. Okay, it took about 30 seconds. So let's take a look at the status. Okay, this looks good. No errors. Let's ping an API endpoint for a list of nodes. I'll just search through my history. There we go. Node 5 Evermind net 9200 cat nodes. Oh, looks like node 1 is missing from the cluster. Let's actually try again, but we'll ping the node 1 API endpoint instead. Okay, node 1. Oh, error. Okay, security exception. So node 1 definitely couldn't join the cluster. Let's look at the var log elasticsearch esdemo.log file. Oh, there we go. I see the error. Master not discovered or elected yet. So the issue is that the elasticsearch.yml file for node 1 is missing the field discovery.seedhost. If you recall, we used the command line tool elasticsearch reconfigure node and an enrollment token that was made from node 1 to set the discovery.seedhost field on nodes 2 to 5. This way, nodes 2 to 5 knows which host to talk to get information on how to join the cluster. However, we never set the discovery.seedhost field on node 1. We never ran the elasticsearch reconfigure node command with an enrollment token on node 1. That's because node 1 was the first ever node of our cluster, and it didn't need to connect with any other node. But when we restarted node 1 just now, node 1 left the cluster. And after node 1 left the cluster, it didn't know how to rejoin the cluster. It couldn't rejoin the cluster because it didn't have the discovery.seedhost field. So to fix that problem, we just need to manually type in the discovery.seedhost field for node 1. So let's go ahead and do that. Okay, I'm back in the YAML file. This cluster.initial master nodes, I could leave it here if I want to, but it doesn't do anything anymore. So I'll just delete it for now. Next, I'll just scroll up, and around here, I'll type in the discovery.seedhost. In terms of which host I should list here, I should list the most stable ones. That way, node 1 will always find a host to connect through. If I list too many hosts here, I think it just means I have a longer list to maintain. I can't really think of any other problems. Also, it's okay to put in hosts that are temporarily unavailable. Elastic will iterate through this array of seed hosts until it finds one that node 1 can connect to. So let's just start filling this out. I'll copy and paste the IP from node 5 first. And there we go. And port 9300 is the default port. If I had omitted 9300, Elastic would have used it anyway. I might as well copy the other 4 hosts here. 5 seed hosts isn't that much really, so let me just fast forward through this copy and paste. All right, that should be good. And I think now we can try to restart node 1. I'll give it a moment. Okay, let's ping the API endpoint to see if node 1 is part of the cluster now. So node 1 evermind net 9200 underscore CAT nodes, just to see. All right, there we go. So node 1 is now part of the cluster. This reminds me, when we used Elasticsearch reconfigure node command on node 2, the command only added node 1 to the discovery.seed host field of node 2. The command didn't add nodes 3, 4, or 5 to node 2 seed hosts. This is because at the time, nodes 3, 4, and 5 didn't even exist yet. So just to be consistent, I'll go to nodes 2, 3, 4, and 5, and I'll make sure that they all have a seed host list similar to the one we just made for node 1. So I'm just going to fast forward this because it's really just copy and paste IP addresses. Okay, all the seed hosts should be updated now. I pulled up the documentation on discovery, and in here it will go through in more detail everything we discussed about the seed host. So I think if you get a chance, you should definitely read through this. The other section you should read through is the one on quorum-based decision making. It talks about how a master node is selected within your cluster. The one thing that you should definitely pay attention to is this sentence that I have highlighted here. And I'll read it out. To be sure that the cluster remains available, you must not stop half or more of the nodes in the voting configuration at the same time. So I want to take a few minutes to actually demonstrate this. Right now, you see that node 2 is the master node of my 5-node cluster. Let's say I stop node 1 and node 5 at the same time. That's removing 2 nodes out of 5 nodes. That's less than half of the nodes in the cluster. This means the cluster will still be up with nodes 3, 4, and 2. Next, if I stop node 3, that's just removing 1 node out of 3 active nodes. That's less than half the nodes of the cluster, and this means the cluster will still be up with just nodes 4 and node 2. Next, if I stop node 4, that's removing 1 node out of 2 active nodes. That is half of the cluster. This means the cluster will be down. If I type systemctl status elasticsearch on node 2, systemctl will say that Elasticsearch is up on node 2, but there will be a lot of errors in the logs of node 2 saying it is not fully functional. There is also an interesting consequence to all this. So let's say I also systemctl stop Elasticsearch on node 2. Then I systemctl start Elasticsearch on nodes 1, 5, and 3. Although systemctl will report that the Elasticsearch service is running on 1, 5, and 3, you will find that the cluster is still down and that 1, 5, and 3 are not functional. This is because node 2 was the last known master node, meaning node 2 was the last node to have the most recent information about the Elasticsearch cluster. And the Elasticsearch software will not let other nodes like 1, 5, and 3, which have stale data, to go rogue and cause a split brain effect. Node 2 must come back online first before 1, 5, and 3 can synchronize with it and be fully functional. So let's demonstrate all this. So let me shut down node 1 first, and then shut down node 5. So that's stopping 2 out of 5 nodes. That's less than half of the cluster nodes, and therefore the cluster should still be up. Let me ping node 2. Great, the cluster is still up. So let's go to node 3, and I'm going to stop it here. So that's stopping 1. Oh, hold on, systemctl stop Elasticsearch. So now I'm stopping 1 out of 3. That's still less than half. So the cluster should still be up. Great, it's still up. Now let me open up node 4. Here it is. Let's stop node 4. And 1 out of 2 is half, and therefore the cluster should be down. So let me press enter. Great, I'm not getting any response, which is what I expect, because I expect the cluster to be down after node 4 is down. Next, let's test Elastic's safeguards against the split brain effect. So I'm going to shut down node 2. And with node 2 being the last known master, I shouldn't be able to start up a cluster with 1, 3, and 5. So let me start up 1. And let's turn on the Elasticsearch service for node 3. And let's turn on the Elasticsearch service for node 5. Okay, so the Elasticsearch service should be up for 1, 3, and 5, but the cluster should still be down. Let me ping the API endpoint. All right, I'm going to ping node 1. Great, I'm seeing an error. So node 1 is not functional, and the cluster is down. And we need to bring node 2, which is the last known master. We need the last known master to be back online before the entire cluster can be up. So I'll start node 2. And now let's take a look at the API. Great, the cluster is up with all 4 nodes. And let's go ahead and bring number 4 back as well. And now we have our full cluster again with all 5 nodes. So we just convinced ourselves that Elastic can protect against the split brain effect. The last known master node must be online before any of the other nodes will form a cluster. Next, let's install Kibana so that we have an interface to interact with our Elastic cluster. I pulled up the installation instructions here, and it's pretty much like Elastic. Get the public signing key, a dependency, a repository definition, and then just finally install Kibana. This is a new instance of Ubuntu 20.04 that we will install Kibana to, but let me update the distribution, apt dist upgrade, and also install some of the typical things I need like Vim, curl, newpg, and gbg. So while this is installing, I'm gonna go to the Elastic node. I'm gonna make a copy of the Elastic installation script and just edit it to install Kibana instead, because the installations are pretty much the same. The only difference is I just need to change Elasticsearch to Kibana. Okay, I'm gonna SCP this install-Kibana script over to the Kibana server, and we will run it as soon as the OS updates are done on the Kibana server. Okay, the updates are done. Let's just run this install script, and I'll pause until it's done. Okay, the installation is done. Let's go to the etc Kibana directory, and in here you see the YAML files that come with the installation. Let's open up Kibana YAML. We can get Kibana up and running by editing some of the configuration details here. There's only a few fields that we need to edit, so I'll just explain the ones that we're about to edit. The first field is server.port. We'll use the default 5601, but you should consider using something that's not the default for more security. For the server.host, I'll use a non-loopback address, so 0.0.0.0. And for the public base URL, it'll just be the URL that we're gonna connect to from our browser. Next, let's edit the elasticsearch.host. And in here, I'm just gonna list each of the nodes URL so that Kibana can connect to any of them. So one of them would be node1 evermite.net, port 9200, and also node 2 and node 3, and then also node 4 and node 5. You only need to list a few stable nodes here. You don't actually have to list them all. Next, we need to provide credentials for Kibana to connect to the cluster. We can do this with either a username and password, or we can do this with a service account token. I prefer to do this with a service account token. I'm going to pull up the documentation. Here, you can see that we can ping the Elastic REST API to generate a service token. All we need to do is specify a namespace and then a service. If I click on the service accounts, I can see the list of available services. The one we want is Elastic namespace and Kibana service. So let's try setting this. I could paste the token right into this kibana.yml file, but I don't like leaving secrets in plain text in this file. If hackers gain access to this server, they would be able to read all the contents of this file. So what I'm going to do instead is encrypt the secret in a key store and only load in the token on startup. I'm going to go to the USR share Kibana binary directory. So in here are the list of command line tools that come with Kibana. So I'm going to use the Kibana key store add. I'll paste in the field that we want to set. And now I'm going to go to node 1 to generate the actual token. Actually, it just occurred to me, to make the service token, we're making a REST API call, which means I could have ran the curl statement from any machine. It doesn't have to be from node 1. But since I'm already on node 1, I might as well continue from here. curl-u elastic abcd1234. Oh, and this needs to be a post statement, so -x post. And then I'll do the URL to node 1, 9200. And now let's grab the endpoint, which is this, and I'll paste here. And now let's give our token a name. I'll just call it Kibana_token. Can be anything you want. For the service, it's Kibana. And for the namespace, it's Elastic. Enter, and there's our token. So I'm going to copy this. So copy this. Then I'm going to go back to my terminal window for Kibana, paste it here. And now this value should be part of the Kibana key store. So let me go back to my Kibana directory. And in here, you can see the kibana.keystore file. If I open it up, our service account token is actually encrypted in here. So next, I have to change the ownership of these files to Kibana, just to make sure Kibana can read them. And I think that should be it. Let's go back to the YAML file. All right, we're done with the service account token. So let's move on. For the Elasticsearch SSL verification mode, we will set it to full. We can do this because with the Elasticsearch nodes, for their HTTP protocol, we decide to use publicly signed certificates from Let's Encrypt to do the encryption. If you are running into issues with SSLs, then as a temporary course of action, you can set the verification mode to none. but you probably don't want to do this as a long-term solution. If you are using Elastic self-signed certificates, then you might need to copy over those certificates from the Elastic server onto your Kibana server, and then reference them with these fields here. I haven't done this often, so if you run into issues, let me know and I'll see if I can post a follow-up video around this. And I think now we can actually start up Kibana. So let's try things out. Daemon reload, enable, and let's start. This could take a moment. It's been about 30 seconds and the website is giving an error, some SSL error, and I know what the reason is. If I go to my kibana.yml file, and if I scroll up, here I say HTTPS for my URL, but I actually forgot to upload the Kibana Let's Encrypt SSLs. So I'm going to do that now. Let's actually make a directory on the Kibana server. I'll call it the certs directory, and inside the certs directory will be the kibana.evermite.net directory. Then I'm going to go to my local machine where I already have the Let's Encrypt SSLs here. I'm going to secure copy the Let's Encrypt SSLs onto the Kibana server at this directory. Whoops, made a mistake, has to be one more directory down. Okay, so let's go back to the Kibana server. Let's take a look. Great, everything is here, but I have to change the ownership. It has to be owned by the Kibana user. And then let's take a look again. This looks good. And now let's continue editing this file. We need to type the full absolute path to the certificate. It can't be a relative path like the Elastic server. This has to be an absolute path. So full chain1.pem. For the key, it's just going to be the priv key1.pem. And now let's try again. Restart Kibana. Let's take a look at the status to see if any issues are coming up. All right, it'll take a while, so I'll wait. Okay, so it's been 30 seconds. Let's try this now. Great, it loaded up. So let me try to log in with the Elastic super user. That was Elastic ABCD1234. Good, this looks like it's working, and let's just do a quick test. I'll go to Dev Tools, and let me try creating just some random index. I'll call it my test index. And then let's just insert a hello world document. So I'll do content, hello world. Whoops, let me just highlight this. All right, and let's just see if that index is split across a few Elastic nodes. I'll do cat shards, my test index. Great, this index is spread across the cluster on nodes 1 and 2. So let's try another experiment. I want to see what happens if I take out node 1, because we know the index is partially on node 1. So let's see what happens. Stop Elasticsearch. And let's go back to Kibana. Let's check this index again. Great, it's only on node 2 now. I waited a few seconds. Now let's check this again. Now you see that the index is on nodes 2 and 3. So Elastic was able to replicate or redistribute the index across a few more nodes in the cluster to improve the fault tolerance. And that's pretty much it for setting up a cluster with Kibana. Let's summarize all the edits we made. For node 1, we opened the default Elasticsearch YAML file, and then we edited the cluster name, node name, network host, HTTP port, and the cluster initial master nodes. Once we actually got all our cluster up, we went back into the Elasticsearch YAML file and we updated the seed hosts. We also swapped out the self-signed certificates with our own Let's Encrypt certificates. By the time you watch this video, Elastic may have changed the default Elasticsearch YAML file. If that's the case, you may need to make a few more edits, so be careful. For nodes 2, 3, 4, and 5, we followed a different process for the nodes to join the cluster created by node 1. On node 1, we generated an enrollment token, and on nodes 2, 3, 4, and 5, we accepted the enrollment token with the elasticsearch reconfigure node command. Then on nodes 2, 3, 4, and 5, we edited the cluster name, node name, network host, HTTP port, and we also used our own Let's Encrypt SSL. We also made sure that the discovery seed host and transport host looked correct. Once the whole cluster was up, we revisited the Elasticsearch YAML file, and we took a look again at the discovery.seed host field to make sure it had all the hosts we wanted. Once the whole Elasticsearch cluster was up, we installed Kibana to a different server, and then we opened up the kibana.yml file. We made edits to the server port, server host, server public base URL, and the server SSL. For the server SSL, we used Let's Encrypt SSLs. We also enabled the elasticsearch.ssl.verification mode, and we also added several nodes to our elasticsearch.host field. I should also mention that we did not have to set up Kibana after all the nodes were part of the cluster. We really could have just set up Kibana immediately after node number 1 was set up. And if that were the case, all we would have needed to add to the elasticsearch.host field is just the address of node number 1. And that's it for this tutorial. If you found it useful, then give us a like, and if you want to stay on top of videos as we release them, then just subscribe to our channel. So we hope to see you in the next video.